Hello, my name is Kate Felton, and I'm a Master's of Teaching secondary student with a major in visual arts at Charles Darwin University. Today I'm going to be talking to you about my unit design for Year 7 Mathematics Spatial Geometry Design Project Unit. I chose mathematics because I'm a visual arts specialist and I felt that it would be the most challenge for me. And I also felt that it would give me an opportunity to integrate some aspects of the arts with mathematics. Unit overview, the strand that I'm working with is spatial geometry, measurement in space. The format will be 20 lessons across 4 weeks, which will be 5 50-minute lessons per week. My class cohort that I've designed for is general mixed ability year 7 class with differentiation considerations for EALD students and students who have additional learning needs. So this unit integrates 2 year 7 content descriptors and a single design-based project at the end. Students will first build deep knowledge of shape classification and geometric relationships. Then they will apply coordinate geometry and transformations before they finally synthesize all that knowledge into a 3D model in their final project. In the design project, I decided to incorporate elements of sustainability as well as design elements so that there's a bit of cross-curricular priorities happening. For this, I'm using Buckminster Fuller's geodesic dome as an example because it's an early and influential model of sustainable design thinking. Nothing too high level because it's year 7, but it's something to get them thinking about how knowledge of geometry can be applied in the real world. And for their final project, they will be presenting a building or an object design. So mathematical reasoning will remain the primary assessment focus of this unit, but the design and sustainability context will provide more of an authentic purpose and motivation. The achievement standard that I'm referring to here is straight from the Year 7 mathematics curriculum for Year 7. So students will be applying knowledge of angle relationships, sum of angles in a triangle to solve problems, and then giving their reasons for it. They will be using formulas for the areas of triangles and parallelograms and the volumes of rectangular and triangular prisms to solve problems. They will describe the relationships between the radius, diameter, and circumference of the circle. They'll classify polygons according to their features. And they'll learn how to represent objects two-dimensionally in different ways by describing their usefulness in this representation. Students will also use coordinates to describe transformations on points of a plane. The 2 content descriptions that I'm working with are featured here. Again, students will be asked to classify shapes and polygons, compare and contrast squares, rectangles, rhombuses, parallelograms, kites, trapeziums, and explain the relationships between them. And as I've mentioned already, they will be plotting points on a Cartesian plane. The cross-curriculum priorities that I'm focusing on are sustainability and the arts, which I think I've described a little bit. Students will design a real-world object with an explicit environmentally friendly element and engage the concept in a manner of designing for a sustainable future. And as I mentioned at the beginning, part of my concept for this unit is that mathematics and the arts share an understandings about pattern measurement and spatial reasoning. And for this reason, I think this unit is appropriately designed. Some of the general capabilities I'll be looking at are numeracy, ICT in the use of the software, and critical and creative thinking, which will happen in the way they justify their classifications, reasoning and relationships, and through design problem solving. Here's the unit at a glance. I haven't gotten too far on designing it yet, just established the topics, the core topic for each of the 4 weeks, and what assessment tasks will be included. This is a rough outline, and I'll continue to elaborate on this throughout assignments 2 and 3. Here I've proposed week 1, lesson 1, a 50-minute diagnostic lesson, where I'll use a starter activity with a shape scavenger hunt, where students identify shapes in photos and around the classroom or school. Then they'll do a diagnostic quiz covering shape vocabulary and coordinate plotting. And finally, we'll have a class discussion to talk about unfamiliar terms and introduce the unit and the design project for the final. The classroom resources and software we'll be using is software called GeoCobra, which is I learned through my research, used for constructing and labeling shapes, plotting coordinates, and applying them. Tinkercad is used for transferring 2D design plans into 3D digital models, so that can be used for their final design project. And then I'll have a number of physical materials in the class for hands-on learning activities. For my out-of-field research, I first familiarized myself with the mathematics curriculum for year 7, and then I narrowed it down to working with geometry for my unit for this project. I also looked at some of the core class texts, specifically the Linda Hobbs text, which helped me get an understanding of how important having adequate planning, resources, and support for out-of-field teaching is. In this instance, I am relying heavily on my colleagues and peers in the unit. Some of their feedback helped me greatly in putting this presentation together, just pointing out ways that I can better signpost achievement standards, reminding me to refer to my own references in research, and making some suggestions on how I can get a sense for what students' prior knowledge is at the beginning of the unit. I also did some outside research just to get ideas for the geodesic dome concept, some of the basic geometries that are used in the real world in architecture and objects, and did some stuff around that just to add that other dimension. And that sums up where I'm at in the planning process so far. I do feel confident in myself to proceed into assignment 2 and assignment 3 with what I have so far. I think the bones are there, but there's obviously a lot more work to do on fleshing out the rest of the unit plan. However, I am very happy with the idea that I have and the core concept and the starting place, and that's thanks to some of the scaffolding in this unit and the feedback from my peers and instructor. So I appreciate your time today. Thank you for listening, and I hope you have a great day.